Hi, and welcome back to DATQVAULT video lectures. This is lecture 1.2. We're going to talk about intermediate nomenclature. In this lecture, we're going to cover how to name alkenes and alkynes. Alkenes and alkynes often show up on the DAT exam, and it's going to be important to know how to identify and name them quickly and easily to get to the exam in an efficient manner. Alright, so we're going to start off by learning how to name alkenes. Alkenes are any hydrocarbon that contains a double bond. Alkenes end with the suffix "ene". So in this 2-carbon alkene, it's going to be named ethene. Over here we have a hydrocarbon alkene that has a slightly longer chain. In this case it's a 5-carbon chain, so we're going to name this one pentene. We can also name it in a different manner by saying pent-1-ene, since the alkene is at the 1 position on the hydrocarbon chain. Alright, so the next thing we're going to look at are cis and trans configurations of alkenes. Since alkenes are not able to rotate around the double bond, the substituents off of the alkene are locked into a specific configuration. Here we have an example of 2-butene, and over here we have another 2-butene. But if you notice, these 2 butenes look quite different from each other. That's because the substituents on this 2-butene are on the same side of the double bond, and in this one they're on the opposite side of the double bond. To denote an alkene that has 2 of the same substituent off of the same side of the double bond, we call it a cis-butene. And the other configuration, where the substituents are on opposite sides of the double bond, are going to be trans to one another. So this is going to be a trans 2-butene. The next thing that we're going to look at are E and Z alkene isomers. We use the E and Z configuration when there are more than 2 different substituents coming off of an alkene. In this case, we have 3 different substituents coming off of this alkene. We have 2 ethyl groups, a methyl group, and a hydrogen. So let's start naming this molecule as if we were just to name a simple hydrocarbon, and that's to find the longest hydrocarbon chain. So this is going to be a 6-carbon long chain with the alkene at the 3 position and also the methyl group at the 3 position. So we're going to name this one hex 3-ene, and the methyl is in the 3 position, so it's going to be 3-methyl. The next thing that we have to do is figure out what the configuration is around this double bond. We do that by splitting the alkene in half and figuring out which substituent on either side has the highest priority. Priority of substituents are based on atomic number of the first atom off of the double bond. So for this ethyl group down here, the first atom off the double bond is a carbon. The first atom off of this substituent is of course going to be a hydrogen. Since carbon has the larger atomic number, this substituent is going to have priority over the hydrogen. When on this side of the double bond, each substituent has a carbon as the first atom off of the double bond. When that happens, we look at the next atom off of that carbon atom. With this methyl group down here, we have 3 hydrogens, and with this ethyl group up here, we have a carbon and 2 hydrogens. Since the carbon has a higher atomic number than the hydrogen, this ethyl group is going to get priority over this methyl group. So now we see which side of the double bond these substituents lie on. Since these substituents lie on opposite sides of the double bond, the ethyl group on the top and this ethyl group on the bottom side of this double bond, they are on opposite sides. So when they're on opposite sides of the double bond, they get the E configuration. So the full name of this molecule is going to be E3-methyl hex 3-ene. Alright, let's take a look at one more example. In this example, we're again going to find the longest hydrocarbon chain. If we start numbering from the left-hand side, the substituents again get the lowest numbers, 2 and 4. And the alkene is at the 3 position, so this is going to be 2,4-dimethyl hex 3-ene. Alright, so then last thing we have to do with this alkene, like every other alkene, is figure out the configuration. Since we have at least 3 different types of substituents coming off of this alkene, we have to give it an easy configuration. If we split this molecule right down the middle, we're going to give the substituents on the left-hand side certain priorities and the substituents on the right-hand side priorities. For the left-hand side, the first atom off of this substituent is a carbon. For this atom is a hydrogen. So this substituent is going to get the higher priority. On the right-hand side, the ethyl group, like we said prior, is going to get priority of a methyl group. Since these substituents are both on the bottom side of this double bond, they're going to be on the same side of the molecule, so they get the Z configuration. So this molecule is going to be named Z2,4-dimethyl hex 3-ene. Alright, the next thing we're going to look at are cyclic and halo alkenes. Cyclic alkenes are named in a similar manner to straight chain alkenes. First, we're going to find how many carbons are in the cyclic structure. This cycle has 6 carbons in it and an alkene, so it's going to be a cyclohexene. Since alkenes get naming priority off of alkyl groups, the hexene is going to be the priority substituent in this molecule, so we actually don't need to number it. The methyl group is going to be at the 1 position on the alkene, since the alkene itself gets priority. So this is going to be 1-methyl cyclohexene. We don't need to give cyclic alkenes cis or trans E or Z configurations because if the cyclic structure is under 9 carbons, it's always going to be in the cis configuration. Alright, let's move on to an example of a haloalkene. Again, we're going to name the longest hydrocarbon chain. Again, it's a hexane chain with the alkene at the 2 position. So it's going to be a hex 2-ene. Our substituents are a bromine and a methyl. Bromine is at the 2 position, methyl at the 3. Remembering alphabetical order, it's going to be 2-bromo, 3-methyl, hex 2-ene. Alright, and the last thing we of course need to do is give it a configuration around the double bond. Bromine has a higher atomic number than carbon. This propyl group is going to have priority over the methyl group. These substituents are on the same side of the double bond, so we're going to give it the Z configuration. Alright, let's do a sample question really quick, similar to one that you will see on the DAT. The question is, what is the structure of Z3-iodo-2,4-dimethyl hex 3-ene? These are your options, so why don't you give it a try, pause the video, and then we'll come back and solve it together. Alright, so let's solve this problem together and see if we got the correct answer. Since time is always of the essence on the DAT exam, it's going to be important to solve this question in the quickest manner possible. Since we're not actually able to write on the DAT, since it's a computerized exam, we're actually giving something similar to a laminated piece of dry erase board over here to write on and then erase our answers once we're done with the question. So the quickest way to answer a problem such as this is to first find the longest hydrocarbon chain in the name. So we know it's going to be a hexane because it's a hex 3-ene. So I'm going to draw a 6-carbon long chain. We know the alkene, or the unsaturation, is going to be at the 3 position on the hexene. So we're going to draw a double bond starting at the 3rd carbon. We're going to put methyl groups at both the 2 and the 4 position on this molecule. And then this molecule also has an iodine at the 3 position. The last thing to do is to figure out if our molecule is now in the Z configuration. We do that by figuring out the priority. Ethyl group has priority over the methyl, and the iodine has priority over this isopropyl group over here because iodine has the higher atomic number. So we notice that since the iodine and the ethyl group are on the same side of the double bond, this is going to get the Z configuration. So now we're going to go through and look at our possible answers. We notice that answer E actually exactly matches our drawing, so we're going to circle E as our answer and then quickly move on to the next question. Alright, the next section we're going to look at are alkynes. Alkynes are any molecule that contain a triple bond. This right here is the most simple of all alkynes with 2 carbons in it, so we can call this molecule ethyne. Alkynes have the suffix -ine, so when looking at this molecule with 6 carbons in it, we're going to call this hexyne or hex 1-ine, since the alkyne is at the terminal position. Alright, let's look at a slightly more complicated example of an alkyne. We're going to start again by numbering our longest hydrocarbon chain. So we notice that the alkyne is at the 4 position. So this is going to be an oct 4-ine. Placing the substituents in the name, there are 2 methyl groups at the 2 position and a methyl group at the 6 position on this hydrocarbon chain. So it's going to be 2,2,6 trimethyl oct 4-ine. Since alkynes are linear, there is no easy or cis-trans configurations around alkynes. Alright, let's look at one more sample question similar to one we will see on the DAT. In this question, we want to know what the IUPAC name is of this pretty complicated molecule. So I'll give you the answers and try your best to solve the problem, and then we'll come back and we'll actually solve it together. Alright, so similar to the actual DAT, we're going to be given a piece of laminate dry erase board to try to figure out the answer to this problem. So the quickest way to figure out the answer to this problem is to first quickly draw out the molecule itself. Alright, so the major difference in all the answers is actually figuring out the configuration over here around the double bonds themselves. So if we can figure out what the configuration is, E or Z, EE, ZE, then we can actually eliminate a lot of these options right off the bat. So when looking at the first double bond on the left-hand side over here, we notice that this cyclopenyl group is going to get priority over this methyl group. This chloral group up here is going to get priority over this carbon chain down here. So since chlorine gets priority and cyclopenyl gets priority, this first double bond is going to be in the E configuration. So let's look at the next double bond over here. This double bond has a hydrogen here and a hydrogen here, so it's really simple to see that this chlorine is going to get priority and this hydrocarbon chain over here is also going to get priority. Since they are on opposite sides of this double bond also has the E configuration. So now we just need to look over here on the left-hand side on the possible answers and figure out which ones have the EE configuration. I'm going to use the X and O method to quickly eliminate options so that I can easily see which ones are still possibilities. Option A is out because it is EZ. Option B is an EE configuration. Option C is out because it's a ZE configuration. Option D is also eliminated because it's a ZE configuration. And option E is also an EE configuration. So already we're down to only 2 possibilities in naming this very, very complicated molecule. So the next thing that we're going to do is find the next major difference between these 2 options, B and E. Here we notice that chloro is number 3 on the molecule, and this chloro group in answer E is number 6 in the molecule. We're actually going to want to start numbering the chain from this side versus this side of the molecule because it gives us the substituents with the lowest possible number. Notice that substituents are at the 3, 2, 2, 4, and 7. Here, 6, 7, 4, 6, and 1. If you add all these up, it's a much larger number than if you add all these up. So our answer is going to be B. So we're going to circle B as our answer and quickly move on to the next question. Alright, so that finishes up lecture 1.2 on intermediate nomenclature, and I look forward to seeing you guys back for the next lecture 1.3 on advanced nomenclature.